Guys, these two components look very similar. Both can rotate, both are used everywhere, but internally, completely different. This one is simple. A potentiometer is basically like a water tap. The more you open the tap, the more water flows. Same thing here. Depending on the position of this knob, the output voltage changes, and that's literally how we control the LED brightness in one of our previous videos. But this thing, it doesn't even know its own position. Like seriously, you can rotate this thing forever and internally it has no idea where it is. So how does it know whether you rotated left or right? How, bro?
There are two contact zones in it.
Yes, inside the encoder, there are basically these conductive contact zones and also these two tiny metal contacts. And these metal contacts keeps touching these zones when the knob rotates. And now whenever this metal contact touches one of these conductive zones, an electric connection is created. And when it's not touching, the connection breaks, which is on and off, zeros and ones. So as you keep rotating the knob, the encoder is continuously creating on and off patterns like this. And of course, by that, the microcontroller understands that there is some movement happening, that someone is probably turning the knob, that's why some on-off signals is happening. But how will the microcontroller understand which side the knob was rotated? Well, there's actually a really clever engineering trick behind this. See, why are there two contacts? Why not just one? Because if we had only one contact, then we would get something like this, which is enough to detect movement, but not direction. So engineers like him added one more contact. You might have already noticed something interesting here. These two contacts are slightly away from each other. Well, that is that clever engineering trick, because now the signals don't become on and off exactly at the same time anymore. One signal changes slightly before the other due to this gap between the metal contacts. And you can actually see this happening here. In this direction, this LED changes first. But if I rotate in the opposite direction, this changes first. And this is actually the raw electronic behavior of a rotary encoder. That's why we are able to blink this LED without a microcontroller. Because a microcontroller is basically like a brain. It will take these signals from the rotary encoder and decides what they actually mean. Maybe volume up, volume down, maybe mouse scrolling, maybe menu navigation, or even controlling machines. It completely depends on the code that you write on the microcontroller. So yeah, all of this direction detection, volume control, mouse scrolling, everything is happening just due to
Two metal contacts.
That's the simple engineering behind the rotary encoder. If you want to try this with our glyph boards, check out the full guide at learn.pcbcupid.com.
See you in the next video.